Hi, my name is Carl Lundstedt. I'm an application chemist at HORIBA Instruments, and I'll be showing the LA960 in this demo. So right now we have the LA960 wet along with the dry powder jet feeder on top. And I'll just talk about what kind of setup we have here in terms of hardware. So over here on the left side, we have our feed reservoir. So this is just filled with water right now, but it could be any dispersion medium, depending on whether you get the S or the A. This is our 960V2 S version. And there we have the vacuum that we use with the dry powder jet feeder. Here we have the water reservoir. And this is our sample bath. So here's where we'll actually be adding sample. So once we feed in water, we feed in about 200 milliliters. It'll be circulating within the system, and we add the sample directly, and it helps disperse the particles within the system, and that's what we measure. This is what the inside looks like without the tray. So here we have our mirrors and our kind of slide. And over here, we have our tray along with all the cells. So the main cell is this one in the middle, this wet cell. So this opens and you can take out the cell and clean it. Behind this, we have the dry cell. And in front, we have a fraction cell. So this holds about 10 milliliters of liquid. So this helps with conserving either a solvent or conserving sample. And in addition, in line with this wet cell, we have our image accessory. So this will help us see what's actually in the flow when we use the additional image accessory and the imaging camera. So I'll put it inside the instrument and show you how we insert it. So here, we slide it on. These red arrows for us, we just need to push it in. Slide it in, and you match up this red arrow with this red line here, and it should click into place. So right now I have the wet cell between the mirrors, so that means we're in wet operation mode. This is for the image accessory. We have our camera here along with a light. So slide in the top tube, connect the top tube, connect the bottom tube. This is just for the fraction cell stir bar. And this is our air line for the dry. And just like that, it's finished. And switching between the two is very easy. So right now we're in the wet cell operation mode. All we have to do is lift up this tray, slide it over, and now we're in the dry cell operation mode. Similarly, if you want to go to the fraction cell, slide it back, now we're in the fraction cell mode. For now, we'll leave it in the wet. Yeah, that's it for the hardware. All right, so here we are inside the software of the LA960. We're currently in the wet operation mode, and I have an Alumina sample on me, and we're going to be measuring this. So the very first step would be to load our conditions. So up here for set conditions, we would click on load and select our condition file. So I've already made one for Alumina. As soon as you create one for a specific sample material, you can use that for all of those sample materials. The most important things among it are the sample name and then the refractive index. So after you set your conditions, the next step would be to feed in the liquid. So once you click feed, there should be water within the sample bath. And then the next steps would be to start the circulation and the agitation. So that gets this back circulation shaft flowing. And this pushes the water throughout the system. And this agitation shaft in the front helps mix the sample when you add it. The next step would be to debubble. And that helps to get rid of any bubbles within the system. So it'll ultrasound, start and stop circulation several times to help free any bubbles within the tubing. Now the next step would be to align the lasers. Only takes a couple seconds. And the final step before we add sample is to blank. So we're saying that this scattering signal we're seeing right now, that'll be our background. And any signal that we see on top of that will be due to the sample, once we add the sample, that is. All right, so the blanking is done. The next step would be to add sample. So I'll shake up the sample, make sure that I get a representative sampling. All right, and then just add a small amount of sample. It depends on the sample size, but start with a small amount and see how far that takes you on the blue transmittance. Right now I'm aiming for 95% on the blue. So somewhere in the middle of this light blue region is how I've set it up. Looks like I'm around 94 or 96.4. I can add a tiny bit more. And wait for it to disperse. Looks like I'm right around 95.5. So once this stabilizes, I can go ahead and take a measurement. And we can see the scattering graph has a lot more signal for these higher channels now. And we can see a result on this live distribution graph. So that gives us an idea of what to expect from this measurement. But once it's stable, we can go ahead and click measure. We don't need to change the conditions because we've already set them, so no. And now it'll do a measurement with the red laser and then switch over to the blue laser and combine the results to give us our final result. So here we can see that our median, or our D50, is 22.8, which is around what I expect for this material. And we have other information like the D10, the D90 on the legend, all of our result data here in the top left, and all of our condition settings for the sample on the top right. So we've got our transmittance, our refractive index, our circulation speed and agitation speed. This can also be represented in a report. So if I go to layout, we can see an example report layout, and you can load from any of the ones that we have by default. And once you're satisfied with it, go to print preview, print. In this case, we'll print a PDF, but you can also print to a printer. We'll save it. And then load it up. And this is your report in PDF form. All right, so we finished with our wet measurement, and now I'm going to switch over to the image accessory software to show what it looks like on the camera, which we have in line with the tubing for the wet cell holder. So here, if I go ahead and click Start, we can get camera images of our sample flowing through our instrument. And we get this live histogram being updated with all the values of the particles that we're seeing. We have a trend graph for the diameter in number distribution. And we can track how many images we're saving as well as how many particles we're saving. And one thing we can do is click capture here, and we'll capture however many images, in this case 10. And you're able to zoom in and look at the particles' shape and size a little more thoroughly. You can draw lines and measure them individually. Another option here is called a trigger. Right now I've set up this trigger to capture any particles greater than 50 microns. As you can see, we have a bit of a tail here. There's occasionally a few particles greater than 50 microns. So say you're very interested in those agglomerates or oversized particles. You can go over to this trigger tab, set up a trigger for a certain size. So everything above 50 microns will be saved and drawn a frame. And you can cycle through all these trigger images and identify all these abnormal particles and size them. So this is a really helpful tool for understanding the tails of your distribution. And once you're satisfied, you can pause and save the data. You can look at the histogram. You can look at the aspect ratio. of your sample, as well as the circularity. So you get some nice diameter and shape information out of this image accessory. And once you're satisfied with your wet measurements and your image accessory measurements, the final step of the entire measurement would be to rinse. And something to note is that this image accessory software is separate, so it can run at the same time as the wet measurement. They're basically separate, so you can choose to run one or the other. And after the rinsing, we've now flushed the system with clean water, and now it's ready for the next use. And that about concludes it for the wet measurement, as well as the image accessory.
HORIBA.